Hello students, we want to find the inverse Laplace transform of s plus 1 squared over s plus 2 to the fourth. Now, in order to make this calculation, we have to use our table of Laplace transforms and also some operational properties, and we also have to do some algebra. So, we know the Laplace transform of t to the n is equal to n factorial over s to the n plus 1. We will make use of this transform in this problem. But we also will make use of the fact that the Laplace transform of e to the at times f of t is equal to f of s minus a. So in this situation, what's happening is s is being replaced with s minus a. That corresponds to multiplying our f of t by e to the at. Now, the expression s plus 1 squared over s plus 2 to the fourth is not written in a convenient way. We're going to have to rewrite this expression in terms of s plus 2, that quantity that is the denominator, s plus 2, and that's what we need. So what we're going to do is this. All it is algebra. So we have the inverse Laplace transform of, if I replace s plus 1 with s plus 2, which is what we want, I'm actually adding an additional 2s. If you were to expand this out, this would be s squared plus 2s plus 1. This would be s squared plus 4s plus 4. So to maintain the balance of the problem, we're going to have minus 2s minus 3. And again, all of this is over s plus 2 to the fourth. So on the next page, what we're going to have to do is now work on this s. This s is going to be replaced with s plus 2. So we'll have minus 2 times the quantity s plus 2. And then this negative 3 is going to turn into a plus 1. I'll let you take a moment and verify that. So what we have now is this. The original inverse Laplace transform we had was, again, s plus 1 squared over s plus 2 to the fourth. After doing some algebra, this ends up being the inverse Laplace transform of s plus 2 squared minus 2 times s plus 2 plus 1 this is over s plus 2 to the fourth. And now what we're going to do is we're going to make use of the linearity property of the Laplace transform and its inverse. So what we're going to have is the inverse Laplace transform of 1 over s plus 2 the quantity squared minus 2 times the inverse Laplace transform of 1 over s plus 2 the quantity cubed, and then our last term is plus the inverse Laplace transform of 1 over s plus 2 to the fourth. So now what we'll do is make use of this table entry as well as this operational property. So think of this as being 1 over s squared with s being replaced with s plus 2. So what we're gonna need to do is multiply by e to the negative 2t. So the inverse Laplace of 1 over s squared is t. So we're going to have t e to the negative 2t for this first term. The second term, well, what you want to do is bring in this 2, because we know what the inverse Laplace transform of 2 over s cubed is. It is t squared. So what we're going to have now is minus t squared e to the negative 2t. Now this last term, we have 1 over s plus 2 to the fourth. You should think of, from the table entry, n as being equal to 3. N factorial is 6, so we're going to have a 1/6 here. It's going to be 1/6 t cubed times e to the negative 2t. So we're going to do some algebra in this problem. And we also had to make use of operational properties.